Automation platforms are designed to make life easier, but when security boundaries fail, automation can quickly turn into exploitation. Today, we'll be taking a look at N8N, what it is, how it works under the hood, and how critical expression injection vulnerability allows authenticated users to execute arbitrary system commands. Before we talk about the exploit, let's quickly understand what N8N actually is. N8N is an open source workflow automation platform built on Node.js. It allows users to build complex workflows by connecting different services together using a visual, node-based interface similar to tools like Zapier or Make, but self-hosted and far more flexible. Internally, N8N is powered by JavaScript and has several key components that make it so powerful. At the core, N8N includes a workflow execution engine that orchestrates how nodes run and pass data, an expression evaluation system that lets users write dynamic JavaScript expressions using double curly braces, code nodes, which also allows users to run custom JavaScript or Python, and over 400 native integrations that connect to APIs and services. That expression system, while extremely powerful, is also where this vulnerability lives. The vulnerability exists in NAN's workflow expression evaluation system. Expressions wrapped in double curly braces are evaluated as JavaScript at runtime. The assumption is that these expressions are in a restricted sandbox. However, the core issue is that the sandbox is not properly isolated. As a result, any authenticated user who can configure workflows can inject malicious JavaScript that escapes the intended execution context and runs code with the same privileges as the NAN process itself. Authentication doesn't meaningfully protect against this vulnerability because once you're authenticated, you're trusted with the expression execution. Let's look at a real world payload that demonstrates this issue. This example comes from security researcher Wee At the high level, this payload does four things: escapes the expression sandbox, accesses Node.js's internals, loads a dangerous core module, executes a system command. Let's break this down step by step. Inside the curly braces, the attacker creates and immediately executes an anonymous JavaScript function. This allows them to run multi-step logic while keeping everything inside a single expression. The key here is the use of this. In this execution context, this refers to the global object, not a restricted sandbox object as it should. From there, the payload accesses processes, which is a Node.js global, providing information about the running process. It then reaches the process.main module, which references the root module of the entire Node.js application. At this point, the sandbox is effectively gone. Using main module.require, the payload loads Node.js's child process module, a core system module that should never be available to user expression. Once child process is loaded, executing system commands is trivial. In this example, the ID command is executed to provide code execution. Finally, the output is converted into a readable string and returned. Now you saw in that short demo how I was able to use the command to then run basic Linux commands on the server, and then I was able to get the flag for the room on Try Hack Me, which is where I did this at, just to showcase, how bad it is.